So the drug I chose was number 184 on the list, Canasa. It says it's generic as mesalazine, but I found it more commonly known as mesalamine when I was looking it up and stuff. I chose it primarily because it has a very simple structure, just an amine, alcohol group, carboxylic acid with a benzene. It has about 400 million in sales. It's obviously a little out of date, but I couldn't find anything more present, at least easily. It is used for the treatment of ulcerative colitis, which is like inflammation and ulcers in the large intestine. And then I guess some facts about it. So it has some bad interactions with a few brands of antacids, not all, but a few. It can be dosed orally or rectally. And then it is one of the top aminosalicylates that is used in treating ulcerative colitis. So then we're going to go on to the mechanism that I kind of drew out to get from this benzene here all the way down to our product mesalamine. So I'm sure. So I'll go over some of the problems later. But started out with an EAS reaction, chlorine and iron trichloride, and that would just put a chlorine somewhere. I just drew it up the top. Moving on, then I did a second reaction where I did sodium hydroxide and water, and this reaction unfortunately would have to take place at high temperature and pressure, which is one of the problems that I saw with my mechanism. I couldn't find any solutions for it. I'm sure with organic chemistry there's probably millions of solutions around this, but I didn't see one off the top of my looking. So then that gets you to this product, which then you just acidify, maybe using just HCl, it doesn't really matter. But then you get to the phenol. From the phenol, we're going to do another EAS reaction. And then the phenol is going to, or I guess the OH group is either going to direct it to this ortho position or the para position. The ortho position I expected to be the major. I don't remember the figures that we looked at in class, but I know that this would be the major. I don't know what kind of percentage we'd see here, but that also might be an issue if we have too much waste, because we're obviously not going to be using this for anything, as it's not going to really be a part. But moving on, then we start the Grignard Mg, it's the MgCl, then we're going to bubble CO2 through it. We'll get to this, and then we're going to add the acid again, maybe HCl, and then we will get to the OH group and the carboxylic acid group here. And then finally, my final step here was to add the primary amine, adding a nitro group. And then when I was looking at this, I saw two spots the nitro group could go, either para to the OH group or ortho to the OH group. So ortho, para. And then I reckoned that this carboxylic acid was going to direct meta. So this bottom slot seemed pretty good for it. I think my understanding is that the major product would be on this second one over here, where it's directing ortho, or para rather, for this OH group and meta for this carboxylic acid. I don't know if there's any like reason that it wouldn't just also direct ortho to the OH group and this would still be meta. I was thinking that maybe because this OH group was in the way, it wouldn't be a major product, but I believe that this would be the major product. I think we'd also see a bit of this second product here. And then obviously we don't just want the nitro group, we want to make it an amine. To do that, we use iron and some more acid. So that gets us to our product. I think the main issues are that we'd have some waste, and we'd also have to use high temperature pressure. I'm sure we could get around that, maybe using some more nitro groups. I know we talked about that in class. But yeah, that's what I did.